Hey guys, it's Mr. Peterson. I'm out sick today, but I didn't want us to get another day behind, so I made a video for you guys to watch to kind of help us stay up to pace. So we had just finished Law of Cosines, and we saw proof for why it worked, and we saw some real-world examples for it. Today we're going to look at the Law of Sines, and I've written it out for you here. That's the A over the sine of angle A is equal to B over the sine of angle B, which is equal to C over the sine of angle C. And so we talked about with triangles with the kind of naming convention. So if this is triangle A, B, C, then side A would be the side that's opposite angle A. So this would be little a, this is opposite little b, so this would be little b, and then this is opposite C, so this would be little c. And so, and at the end of the video, we'll talk about when law of sines comes in handy, but right now, why don't we just go ahead and dig in to this example. So go ahead and, on a blank sheet of paper, let's go ahead and write this example. We'll just do one example today. This is example 1. So go ahead and draw this triangle. It's okay if you freehand it. It doesn't need to look pretty. And this is triangle A, B, C. And by our naming convention, if this is A, big A, angle A, then this side right here is little a. If this is big angle B, then this side over here is little side B. And if this is C, angle C, then this is little side C. And it's a good idea to kind of label these whenever you do them to kind of help keep it straight. Now there's a couple things we know here. We're going to know that side C is 7.35 units. And we also are going to know that angle A is 61 degrees. And we also know that angle C is 43 degrees. Alright, so what we need to do is, when you get these kinds of problems, they'll just usually say solve the triangle, which in non-math speak, what that means is you're just going to find all the missing angles and all the missing sides. Alright, so if we apply law of sines here, the way that it works, it's the side that's opposite the angle over the sine of the angle, and then we're going to set up a proportion and cross multiply to find a missing part. So what you got to do is you got to look for what are the two parts that you know that go together, that correspond. And we know angle C, and we know that side C is 7.35, so that's our first part. So what we're going to do is we're going to say 7.35 divided by the sine of 43 degrees. And so just to kind of, in notation, this is like the C, and then this is little c up there. So angle C and little c. And so what we're going to do is we're going to set that equal to, let's go ahead, we don't know right now what little a is. So let's solve for little a. So we would say little a up there in the numerator, and what we're going to do is we're going to divide that by the sine of the angle that's opposite little a, and that would be 61 degrees. So we have a proportion here. One way to solve proportions is to cross multiply. So we want to go ahead and cross multiply, so that's going to be 7.35 times the sine of 61. Just to jog your memory that the sine here, the 61 is in its own like protective cocoon. You're not going to operate on the 61 at all, so just leave it alone. And so let's cross multiply the other side. So this would be a times the sine of 43 degrees. All right, we need to solve for a. Right now, a is getting multiplied by the sine of 43, and you undo multiplication with division. So we would divide both sides by the sine of 43 degrees. Sine of 43 degrees. Over here, these become a 1. And over here, we would just have a problem that we would use in our calculator. And again, just to jog your memory, the 43 and 61, I know they couldn't cancel, but even if they could, like a 90 and a 60, if they had some kind of common factor, you can't do anything with those. They're in their own protective cocoon. So one last step here. We've got A equals, I'm going to go ahead and flip it. A equals 7.35 times the sine of 61 degrees divided by the sine of 43 degrees. And at that point, you would use your calculator. I'll put this right here. So make sure you're in degrees, not radians. So we would do 7.35 times sine of 61, and then divide that by sine of 43. Hit enter, we get 9.425. They didn't tell us where to round to. Let's just round to the thousandths place. So that was, so what we would say is we are approximately equal to 9.426. And then they didn't give us units either, so this is just units. All right, so we now know what A is. We're starting to get closer and closer to being done, but we're not done yet. We need to figure out what is big angle B, and then what is little side B. So first of all, we can get big angle B simply by using what we know about triangles. We know that angle B, well, all triangles add up to 180 inside the angles. So what I could do is I could do angle B, that would be 180, but take away from it the sum of the other two that we know, 61 plus 43. When you do that, you get that angle B is 76 degrees. All right, so with that piece of information at hand, we're ready to solve for the last side, the last missing side. All right, so now we know all three angles, we know two of the sides, we need to solve for side B. So again, we could use law of sines for this. So we've got one more problem here. So we're trying to solve for side B, so that would be B divided by the sine of angle B, which we just figured out, the sine of angle B, which is 76 degrees. And then we set that equal to, now here's the thing that you could go either way. You could now use, now that you know A and angle A, you could use 9.426 over 60 sine of 61, or you can go ahead and just reuse the sine of reuse 7.35 over sine of 43. It doesn't matter, you'll get the same answer either way. Let's just do C. So 7.35 divided by the sine of 43 degrees. So again, we cross multiply. B times the sine of 43 degrees should be equal to 7.35 times the sine of 76 degrees. Right now B is getting multiplied by the sine of 43, and you undo that with division by the sine of 43 degrees. Again, you cannot cancel with those angles. Don't try to do that. It's going to cause you trouble. Now over here, the sine of 43 over sine of 43 does become 1. So that is B equals, and then you get out your calculator again. 7.35 times the sine of 76 degrees divided by the sine of 43 degrees. Again, make sure your calculator is in degrees. If you used the law of sines last time, you could just go up and copy it and change the numbers around, or you could type it all in again. So this is now sine of 76. Sine of 43 is in the denominator still, so we get 10.457 is our last B. So approximately 10.457, and again, that would be units. Box our final answer, and we solve that triangle. When is law of sines useful? Well, remember, law of cosines is useful whenever we knew a side, or a side, an angle, and a side. Law of sines, on the other hand, is important when you know angle, sine, or when you know angle, side, angle. And so this problem that we did was an example of angle, sine. side, excuse me. So angle, angle, side right there is what we knew. So, so anyway, these are the two situations you could use law of sines. Law of sines usually is a lot less cumbersome than law of cosines. You know, law of cosines has a lot of little steps in it. So if you can look for an opportunity to use law of sines, you definitely want to, but it's not one that you can always use. You need to still use your head and think, is this a law of sines problem or is this a law of cosines problem? Anyway, so I'm going to send out a remind for what problems I want you to do. That's the law of sines. I hope to be back at school soon.